Hi, this is a video for simple harmonic motion pendulum, and I'm going to show you how to find the period of oscillation. So pendulum is a string and a mass attached to it, and it goes back and forth from one side to the other. The center is the equilibrium. If the length of the string is L, mass is M, and then it just goes back and forth. So let's start off with remembering angular velocity, because as you can see, this is actually doing rotational motion. Angular velocity is 2 pi over period. And if you solve for period, it is 2 pi over angular velocity. And angular velocity in the pendulum is g over L. I'm not going to talk about how you find this. In fact, when you plug this in, 2 pi, and then instead of angular velocity, you're going to plug it in g over L, and then you have to take the reverse of that fraction. This equation is on your equation sheet. So let's see what are the variables for the period. It is length of the string and gravity. So mass is not really variable for the period of the pendulum. So this is the first part of the pendulum. And the second thing I would like to talk about is the relationship between these 3 points. So if pendulum is going, let's call this point 1, point 2, point 3, and it is going back and forth. Point 1 and 3 is maximum displacement point. Point 2 is equilibrium point. Okay, so we're going to ignore any friction, and then the mass is going back and forth, and because we ignore the friction, it is going to go forever. Now, the next thing we can talk about is energy at those points. So let's label each point. This 1 and 3 is the maximum displacement, and 2 is the equilibrium point. So if you think about it, at points 1 and 3, the mass will have a height. Because it has a height, this point is going to have maximum potential energy. Same thing here. It is going to have maximum potential energy. As it gets down, it is going to speed up, and that is going to be maximum kinetic energy. And one last thing I would like to talk about pendulum is the forces. So I'm going to draw this again, and let's say from the equilibrium, the object, the mass is making theta, and this is the length, and Fg is going to be towards down, right? And if you think about it, there are 2 components of mass. One of them is this direction, and the other one, if you, let me draw with another colors. So this is one component and that's the other component. And this theta will be equal to this theta. Okay? And then if you look at this one, this is going to be mg times cosine theta, and this is going to be mg times sine theta. So sine theta, if you look at this triangle, and if you call this x, it's going to be opposite over hypotenuse. And what does that mean? Fg, which is mg times sine theta, will be equal to mg times x over L. And those are the forces on the pendulum.